Welcome to the Blue Security Podcast, a weekly podcast for information security defenders, where we bring you discussions on best practices, tools, and implementation for enterprise security. Now, here are your hosts for today's show, Andy Jha and Adam Brewer.
Welcome to this week's episode of the Blue Security Podcast. I'm Andy, your host.
I'm Adam, your co-host.
This week, I'm going to go over this blog article that was written by Alex Weinhardt, who's one of our executive folks in charge of identity. He's been in identity for a very long time. He's been at Microsoft for a very long time. And the blog article is a few months old, so you may have missed it. I've been meaning to talk about this on the show. And so it's really good. It's talking about protecting against token theft. And token theft has been in the news lately. But as a baseline, anytime we're talking about identity attacks, MFA is going to be the thing that you want to turn on in order to prevent the majority of identity attacks, password attacks. The issue is that attackers are now going after the tokens and essentially kind of bypassing or attacking MFA. And so how do we defend against that when the attackers are going against something that is our number one defense? But before we get into that, you might not know what tokens are. So let's just talk a minute about what are tokens. Adam, can you give our listeners kind of a 101 on what tokens are when it comes to identity?
Absolutely. So tokens, and this applies across almost any identity provider you're doing. There's been kind of a migration to a standard model of doing identity, and whether you're using Okta or Ping or Entra or Google's identity or Facebook identity, they all operate on more or less the same concept. So the good news is, as you learn these concepts, they're mostly transferable. There are nuances between different implementations, of course, but for the most part, these concepts are transferable. And that's because a lot of identity today is built around standards, things like SAML, OpenID Connect, to name a few. So what is a token? Well, a token is an authentication artifact that grants you access to a resource. Or put more simply, it's something you can show, think like a hotel key, to let you into your room. That would be an example of kind of a real life example of a token. And so you get a token when you sign into your identity provider. And at first, it's going to do authentication, validate your identity. And there's various ways to do that. And that happens before tokens get handed out. So think of tokens as separate from that authentication process. And so once you successfully sign in, then that identity provider will issue a token that describes who you are and what you have permission to do. Now, when you want to go access an application or a service, we'll just say app from here. You get permission to talk to that resource by presenting a token that's currently signed by an issuer it trusts. So that's where, for example, let's say you use Salesforce, but you use Entra as your identity platform. You can create a trust between Salesforce and Entra, where when Salesforce is presented with a token from Entra, it will say, yes, I trust Entra for this scenario. Come on in. Now, the software on the client or the device you're using, it kind of takes care of all this behind the scenes. So you don't really need to worry about it, except when it comes to things in our security professional mindset, where it impacts our ability to secure our organizations, like when tokens are stolen, as an example. So the first token you get when you sign into this identity provider is called a session token. And that shows you've successfully signed in and how you signed in. And so when you sign into an app, you show that session token and exchange it for something called an access token, which gives you access to a specific resource for a certain amount of time without having to do re-authentication. Now, this is an important concept as well, that token exchange can happen even when you are not, as a end user, being prompted to re-authenticate. So this is an important concept I always land with folks, that there used to be this perception, if I'm not forcing a user to manually re-authenticate, put in their username, put in their password, provide their multi-factor authentication, there's no check to validate that's still the right person. That is false because session tokens usually last longer than access tokens. Access tokens have a shorter lifespan. And if the token expires or there's a change in risk, the client will go back to the identity provider and ask for a refresh. Now, if nothing has changed and I say, hey, my access token expired, it's been an hour, I'd like another one, please. And it says, well, Adam, your password hasn't expired and you're using the same IP range and computer you were before, nothing's changed with your risk. I'm just going to give you another access token. Sounds good. But there's that evaluation that happens all of the time, every time those tokens are exchanged, and even more frequently in modern identity providers like Entra. So a stolen access token is bad because that might grant the threat actor access for, say, an hour. But a stolen session token is particularly bad because now that threat actor can mint new access tokens and keep accessing stuff indefinitely. Again, until there's a change in risk or a change in the user or something to trigger actual reauthentication, not just a token exchange, which is, again, that thing that happens behind the scenes.
Thank you, Adam. Now that we have an idea of what tokens are, how do attackers steal these tokens? Well, generally, they're done through the use of malware on the client to acquire like a token. And that's one method. But other ways, they can also copy tokens from the network as they pass through a proxy or a router, or you can extract tokens from an unsecured server logs of like some other party. And so there's multiple ways to do it. We have talking about a tool called Evil Jinx that a lot of attackers will use to try to steal tokens. They have these tools that the initial vector of attack is usually some sort of phishing or link, malware, something like that, that eventually gets you to get access to the attacker, and then they steal the token using some other program.
So let me jump in 1 second. So as our listeners are listening to this, how do I protect against this? Step one is still great email hygiene, other malware vector hygiene, preventing malicious files, links, attachments, emails from coming in your environment, and training your users not to click on suspicious links, suspicious files, etc. That is still step 0 in prevention here. And then we'll talk through from there. But just want to land that message again. When organizations are saying, I'm getting hit by this all the time, it still comes back to you will never train your users to never click. 0 clicks is not a thing. You will never eliminate all true positives from coming in to your environment, but it still starts there in terms of anything you can do to whittle that down is going to help eliminate the need to do some of these prevention steps moving forward. But obviously you're going to, because stuff's always going to get through those first couple of steps.
Yeah, everything is about the basics. You definitely need to have the basics. And I think a lot of organizations look for some magic new tool that comes out, which we are going to talk about. There are some new things that we're going to talk about here, but we're also going to talk about just some practical things that are baseline. And Adam kind of gave you a taste of that, which is you got to still have good email hygiene. You got to still have good endpoint protection.
And user training.
Yep. Thanks. And so the new magic tool essentially is we have this new thing called token binding, which essentially a token that's issued should only be used and work on a device that it was issued to. And so if that token was stolen and then replayed on a different device, like the attacker's device, it should be rejected. And so that's this thing that Microsoft has developed called token binding. And these are cryptographically tied to the device that it's been issued to. And so once you have this protection in place, it essentially makes the act of stealing the token useless because it can't be replayed. The biggest thing that we have to do now that we have token binding, is get the developers who are coding their programs to enable the use of protected tokens so that you can enforce a new condition within Entra conditional access to require that application to use protected tokens when they're accessing a service. The policy will reject any type of token that's not cryptographically tied to the machine. So, understandably, it's going to be a long road before we get there to the point where we can enforce token protection on every single application across the stack for Entra, because the developers do have to recode them to allow us to use this token protection. Right now, in public preview, you can protect sign-in tokens, session tokens for native applications on Windows devices when you're accessing Exchange, SharePoint, and Teams services. It is limited to Windows 10 or 11 that are Entra joined, Entra hybrid joined, or Entra registered. And the native clients that are out today that you can enforce this on are OneDrive, Teams, and Power BI Desktop. Important to note that the Office perpetual clients aren't supported. And then as we continue this development, support for Azure management scenarios, web applications that are accessing M365 resources, and cross-platform capabilities to Mac, iOS, Android, and other clients are going to come out over this next year. So it's going to be a long road, but we do have some today. And that's the new thing, is token binding, this token protection that is already in as a condition within Entra's conditional access.
Yeah, it's important to note, again, this timeline, Microsoft starting with technologies it controls end to end. So Windows and Teams client and that sort of thing. Everything in Entra is built around industry standards, things like OpenID Connect, which I mentioned earlier. So some of this is trying to kind of commit these standards or commit these changes to these standards and get these standards bodies to recognize them. That's some of the work here. And working with other operating system vendors, obviously, it will require collaboration with Google, with Apple to ship these changes on other platforms, because I think it's going to require an interplay of operating system plus application to get all the way there. So start with what you can control. And again, start with workloads that are popular, but maybe not the most popular or most complicated or most mission critical to start, and build confidence, and that snowball starts to roll downhill and pick up momentum as it goes further down the mountain. So this is certainly encouraging. And it's probably one of those things where if you're listening to this and you're not deep in the identity realm, you may say, my goodness, why weren't tokens always bound? Why was there ever the opportunity for token replay? Why could they be passed from client to client? And I think in general, attackers are have a high level of ingenuity. And when we design standards, we don't always predict all the malicious ways they would be used. If you look back to a lot of the standards we use today, they were designed in a time where there just weren't the assumptions of the threat environment there are today. Email, I mean, amazing example where we have kind of bolted on a lot of security on top of it, but it was built in the 1960s when the only people on the internet was the Department of Defense and a bunch of universities. Like, there were no threat actors. And so you could just trust what happened. And bringing that into the modern world has been difficult and not without growing pains. And although a lot of these identity standards are not as old as internet email, there are some similarities there in terms of having to bolt on security over time. And, think about this. I used the analogy earlier of an access token is a lot like a hotel key. It's only active for a certain amount of time. But if someone else gets access to that, then they can access my room. Well, there's benefits from that in that model because I can hand my key to someone else. But imagine if when you went to the hotel and before they would issue the key to you at the front desk, they had to bind the key to you. Like the key had, say, an iris sensor or a fingerprint sensor built into it, and you had to bind it to your identity before you left the front desk. And so then there was no transferability options with it. Now, that's not a great analogy because, again, you may say, well, I never want a token to be transferable, and that makes sense. But just in terms of the complexity of adding binding to the top of it, when you could just say, just protect this, like it's a key, like don't let somebody else have it. Well, easier said than done sometimes. So that's why we've kind of had to bolt the security on over time, but really exciting development. I see this as an extension of the continuous access evaluation Microsoft shipped several years ago now, where when we described the token model, or I did at the top of the show, I used the example of a 1 hour lifespan for an access token. And that used to be how it worked. If you got an access token, it was good for an hour and they were irrevocable. You could not revoke them out in the field. Once someone had an access token, it was good for 1 hour regardless. And today, continuous access evaluation does more of that real time, building in the ability to revoke them and validate if they should still be allowed all of the time, as opposed to only on a 1 hour interval. So there's been a lot of innovation and iteration in this space. And I'm sure the folks over at Ping and Okta are doing similar good work here. But taking a lot of these standards that frankly had too much trust built into them, and bolting security onto them and making them much more secure is a hard engineering problem. And you get there iteratively. And so proud of the progress, but obviously more to do. Would love to see this extended in the near future to things like, I don't know, Outlook as an example would be really awesome. So we'll see that. And then with the web apps as well. So it's all coming, but be patient. And there is a chance if you want to kick the tires on this, you can try it out today. And if you're a Teams shop, I mean, Teams is certainly a heavily used app, and you can start running that now in your environment and see how it works and provide feedback.
Yeah, absolutely. I think in the blog, it actually talked about how token theft is not a huge problem. It's maybe 5% of all of the identity attacks, but we have seen a rise in the token theft arena. It's one of those things where, it's like the buzzword of the security news. It's this new fangle attack, and now we're innovating and coming up with different ways to protect against it. But as we talked about at the beginning of the show, there are still a lot of things that you need to do as baseline that will help mitigate this. So we talk about some practical steps: reducing the risk of successful token thefts, preventing the malicious use of them, and then being prepared to detect and investigate attacks. So when we talk about reducing the risk of a token theft, the first thing, and if you're a listener of the show, this should not be a surprise to you, the first thing that Microsoft recommends is require a managed and compliant device. You would be surprised how many customers that Adam and I talk to. We work in our field sales at Microsoft, if you've been listening here. And, as part of that, we talk to a lot of customers. Microsoft's not a sponsor of this show. We do this on our own time, but we do talk to these customers and we get a lot of feedback. And, you'd be surprised at how many of them are still not running managed and compliant devices for all of their organization. Today at Microsoft, if you had my username and password, there is nothing you can do. You can't access anything until you get a managed device. And you can't do that unless you have MFA. And in some cases, you have to have a passkey. And actually, in all cases now, you have to have a phish-resistant passkey or a FIDO2 key. And so unless you're here and you're breaking my arm and making me sign in, you're not going to be able to do anything. And hopefully at some point, the majority of orgs are going to get to that point. But yeah, you got to get to managed and compliant devices using conditional access policies to make sure that that device is compliant. At least, I think majorities of companies are now at hybrid enter join. If you're there, you can at least require a conditional access policy to say must be hybrid enter join. But that's only part of it. You got to move at some point to co-management, let Intune take over the compliance policies, make sure that you have compliant devices. There's other things in here like making sure your storage is encrypted, obviously, LSAS protection, which is enabled by default on all new devices, but you can enable it for other devices via Intune, jailbreaking and rooting detection on mobile devices, which of course you can do again through Intune, and then turn on Credential Guard. We did a whole show on Credential Guard, why it's important, and you should turn it on. It is enabled by default, again, for devices that are running, but if you haven't done it on the older devices, or for some reason, because we didn't go ahead and turn it on for existing devices that upgraded in place, it's only devices that started with 22H2.
Mm-hmm.
So go back and turn that on. And that protects your Active Directory credentials by using virtual-based security to isolate those local and cache credentials so that you can protect against stuff like pass the hash. So that, right in a nutshell, is a lot for most organizations to do, but it is baseline. It's something that we highly recommend that you get to.
Yeah, the point here of everything Andy's gone through is if somebody steals a token, you say, so what? Good luck with that. And if you're requiring managed and compliant devices, that is certainly a huge step in the right direction. Um, Andy, let's see. Did you have this? You had this elsewhere. Okay, so yeah, reduce the risk. Okay, we've got more. I was looking at the rundown. The managed and compliant devices, just to Andy's point, and I know the poor horse is dead. If you are hybrid joined, and you probably are, and if you're using SCCM, and you probably do, it is trivial to deploy Intune in a co-managed state for your Windows devices. And you don't have to shift any management, any app deployment, nothing. You can just move that slider for compliance checking, and you can write a compliance policy in Intune to look for stuff you need to look for. And then you tell Entra ID to require that. And you have just massively upped your security game. For all listeners of the show, Andy, you talked about on our 4-year anniversary show, like our goal is to provide actionable guidance on this show. My goodness, if you're not doing that, go talk to your device management team. You're hearing this on Tuesday. Go talk to them tomorrow. Set a meeting on their calendar for Wednesday and be like, why the heck aren't we doing co-management and running compliance policy checking on the Intune side? And what help do you need from me to get there? And how soon can we do this? Because if you want to up your game in security, I can't think of a bigger win than requiring managed and compliant devices for accessing resources. It's just good practice at this point, and it's well overdue. And again, Andy and I, we see tons of customers. We talk to tons of customers. Very few orgs are doing this, and it blows me away every day because this is not an insurmountable hump to get over to do this. You don't have to stop using SCCM. You don't have to enter join your devices. You don't have to change anything. You don't have to redeploy devices in the field. You don't have to wipe them. Nothing. It's not that hard to get there. And it's a great first step, and it sets you on the right path forward. But this is a huge win you could get now. So please take a look at this, get it going. And if you're not using Credential Guard, kind of the same thing at this point. Talk about low-hanging fruit. Get it done. These are two huge, huge wins. We're begging you, please, to get these knocked out. I love seeing that Credential Guard ships by default in 22H2. And even one of the exciting things about these Copilot PCs that have recently launched and will soon extend to Intel Silicon and AMD Silicon as well, is there are very strict security standards around Copilot Plus PCs. All of the things that must be enabled by default out of the box, including like Windows Hello Enhanced Sign-On security. We continue to up the game for what's on by default in Windows. And I think that, especially for our audience and listeners of our show, is a huge, huge win. So love to see that keep marching forward.
So when we talk about preventing the use of stolen tokens, you want to start by making a conditional access policy for this token protection. You can do that today, at least for the apps that are available. Like we talked about the apps that are available, but Microsoft is continually updating the apps, and hopefully other application developers will follow suit. And you always want to be using the latest version. So make sure that you test it, configure a conditional access policy to require token protection for sign-in sessions on these applications, the Teams client, the OneDrive, and Power BI. And as more apps get updated, and you should update that conditional access policy. If you are a customer or an Entra P2 customer, you can create a risk policy. So risk-based conditional access will help prevent the use of stolen tokens as well. That's when the sign-in risk or user risk goes to medium or high. You can then require them to re-authenticate or do another MFA prompt in order to get that new access token. So that will make it more difficult for the attackers to initiate a session using these stolen session tokens.
One point of clarification there, that is specific to session tokens, which Andy did say. Remember, the session token is the one I can exchange for access tokens with different apps. This doesn't help with the access token theft because that access token is already stamped saying you've already done MFA. You don't need to do it again, so you can come on into the app. So risk-based conditional access doesn't help with access token theft. The good news about that is it has a limited lifespan, about an hour, but it does help with those other scenarios like session token theft and preventing that re-authentication, because the attacker may have stolen a session token, but hopefully they haven't stolen those second factors your users are using. And so when the re-authentication prompt hits them because their risk changed, the attacker can't satisfy that, and now you've locked.
And then Adam talked about the continuous access evaluation, or CAE. that can automatically invalidate tokens when Entra ID protection raises the risk of a user or a service principal. So this can trigger the risk-based conditional access policies as well and mitigate them in real time by requiring re-authentication. You can also reduce the risk of token reuse by restricting the sessions to a specific network boundary. So obviously, I wouldn't say obviously, but like most of the time, the stolen tokens are going to be used outside of an untrusted IP. So you can establish network boundaries with policies to make sure that if they are coming from unknown location or known bad location, to block that. We talked about some of the things in Entra Suite as part of our security service edge solution. So Entra private access and Entra internet access. And you can use this if you're a customer and you're actually using these solutions, you can use that as a network condition as well to require them as part of your conditional access policy to be coming from one of those IP addresses or compliant networks as part of that condition access check.
So I want to add a little bit of additional detail context around what Andy just talked about with the network locations. So if you've been listening to the show for 4 years, you know Andy and I are really down on and continue to be down on using the network location of a sign-in as a reason to reduce the requirements elsewhere. For example, we used to see a lot of organizations say, oh, well, if you're coming from a trusted network, you don't need to do MFA. We still do not recommend that, to be crystal clear. In fact, I think every sign-in every time should always require multi-factor authentication, but the user experience should not be they get prompted all day, because of the default settings in Entra would not require that. If nothing else has changed, user doesn't get reprompted. Now, what we're talking about here is using the network signal as an additional signal to build trust in a sign-in. Just as we walked through using things like user risk and sign-in risk and a managed and compliant device, and using those to build trust in a sign-in, the same is true here. You can use the network location to build trust in the sign-in. Now, the benefit of using the Entra Secure Service Edge for that, the Entra Internet Access in this case, is that Microsoft still does not recommend hairpinning all of your Microsoft 365 traffic back through your on-premises network through your VPN. So while yes, you could tell users we're going to use an always-on VPN, there's no split tunneling, then we're going to require that in our conditional access policy. In theory, yes, that's going to build more trust and reduce your risk of token theft. However, your users will have a degraded experience in Microsoft 365. They'll have more latency. Everything will be slower and degraded compared to the experience they could have. So the benefit is with Entra Internet Access, you don't have that problem. It remains performant, low latency, high bandwidth experience, but you are still looking for that additional factor of this sign-in must originate from the Entra Internet Access service in order to be allowed to proceed. And when an attacker steals that token, they don't have that. And Entra says, yeah, this token's no good here. And that is a beautiful thing for you. So just wanted to add some clarity on using network as an additional trust factor, or to build trust, I should say, in the sign-in, as opposed to a reason to reduce your other security requirements, which you absolutely still should not do. But I'm seeing almost a little bit of a renaissance in terms of we can use the network to build trust elsewhere, and that is not a bad thing. It just can't be the only thing or the only signal we look for and as an excuse to reduce security elsewhere.
And Microsoft is doing this today with some of our applications. I have been denied access to some internal apps, even though I'm on a managed device, I have MFA, I have a passkey. They still require you to be on VPN and come from a specific IP address. So it's not a bad thing to layer on more security. It's bad when you relax it and make an exception because you're coming from a trusted IP.
Succinctly put, yes. Well done.
So finally, you want to be prepared to detect and investigate any attacks that are using stolen tokens. Now, from the Entra side and the Microsoft side, we have Entra ID protection and Microsoft Defender. Now, whatever service that you're using, if you're using Okta or Ping or Duo or whatever IDP, you're going to want to ask them, do they have alerts for token theft? And same thing with your EDR. Do they have alerts for possible attempts to access the primary refresh token or the PRT? And that's for the device. So with Microsoft solutions, we do have new alerts built in when a threat actor tries to replay a token or the sign-in event triggers like a anonymous token or an unfamiliar sign-in properties, detections such as like an unusual token lifetime or a token played from an unfamiliar location. Token attributes are unusual and match known attack patterns. So those are things that we've built into our solutions. Definitely check with yours to see if they've updated, because I think this was pretty new in the last 6 months to a year that we came out with these type of alerts.
Yep, agree.
And then finally, of course, the final thing, which is basic to anyone who's in security, pull all of your data into a SIM. Ours at Microsoft is called Sentinel, and you can use that to investigate potential theft. So if you're receiving an alert, you can pull it into a SIM and get specific details, severity, when it occurred, so on and so forth. So you want to be prepared to see the alerts. You want to be prepared to investigate those type of alerts.
Yeah, absolutely. And with these kind of post-incident alerts, some of these are not necessarily real time. They're going to be after the fact, but hopefully you can catch before the attacker's done too much damage or gotten too far. But it's another tool in the toolbox, right? Obviously, we talked about on the show, here's where you can start with prevention. And that's really basic in terms of email hygiene and user training and requiring managed devices. And there's different conditional access policies you can require that basically make it impossible or nearly impossible for attackers to steal these tokens. And we didn't even really get into like preventing the theft in the first place, because some of the things you can do to help with that are require phish-resistant multi-factor authentication, because then the phishing effort itself, like the Evil Jinx server, will fail because the phish-resistant methods will detect, hey, this isn't the actual site, this is a proxy, and refuse to sign in. So there's other ways to prevent as well. But at a certain point, you have to say, okay, well, we still have to have a plan for response. And your response is your IDP should generate alerts. Even better if those alerts are contextualized in the timeline of the incident with information from other services. If you do that in your SIM, awesome. If you do that in your XDR platform like Microsoft does, you would actually see the email that came in, the malicious attachment, you would see it detonate and execute on the endpoint from Defender for Endpoint, and then you would see the identity compromise. And those would all be in a timeline in a single incident automatically correlated. And that really should be your North Star. Whatever you're doing, whatever set of solutions you're using, whether you're stitching together multiple third-party solutions and you're dumping it all in a SIM, like you should be able to go in that SIM and that should all be automatically correlated in a single view so you can track it across security domains. If you don't have that, Microsoft does. I don't know what else to tell you. So it's one of those things of that should be a goal, because that exists. That's not a flying car. And being able to help you do your investigation, because obviously at that point, if you're post-incident, we want to know, did anybody else get this email? Have we seen the signature anywhere else? Has it been on any other endpoints? And let's block that from all endpoints. Let's remove that email from all mailboxes, and then let's go investigate this user. Let's reset their password and invalidate all their tokens and go do an investigation. So having the ability to see all that really seamlessly obviously is going to accelerate your investigation response, and that's really helpful.
Well, great show, Adam. Hopefully everyone learned a little bit about tokens, token theft, and how to protect against them. That's our show for this week. Thanks for watching and listening as always. Our contact information will be in the show notes, as well as a link to Alex Weinhardt's blog. If you have any questions or topics you want us to talk about in the future, please let us know. Thanks. We'll talk to you guys next week.
Thank you for listening to the Blue Security Podcast. Please check out the show notes, catch up on episodes you may have missed, and subscribe so you don't miss any future episodes. Find Andy on Twitter @AJaw0 and Adam @AJ Brewer. See you at our next episode.